Welcome everyone. So today we're gonna discuss about Hamiltonian and Hamilton's equation. So to discuss about Hamilton's equation, we need to start with Hamiltonian. So Hamiltonian of a system represents the total energy of the system, that is the sum of the kinetic energy and potential energies of all the particles associated with the system. So H is equals to T plus V. So Hamiltonian represents the total energy of this system. So H is equals to T plus V, where T is the kinetic energy and V is the potential energy. Now the Hamilton's equations. The Lagrangian L is a function of the coordinate qi, their time derivatives qi dot and time t. So Lagrangian of the system L is the function of generalized coordinate qi, generalized velocity qi dot and time t. So if L be the function of qi dot and t, then we can define the Hamiltonian to be the Legendre transform of the Lagrangian with respect to the qi dot variables. So we can write H in terms of qi, pi and t, which is a function of qi, pi and t, and we can write H in this way, that H is equals to pi qi dot summation I equals to 1 to n minus L, which is also the function of qi dot and time t. So writing the Hamiltonian in terms of the Legendre transform of Lagrangian, we can write H in this way. So now H, which is a function of qi, pi and time t, can be written as summation pi qi dot sum over I equals to 1 to n minus L, which is function of qi dot and time t. So where pi is the generalized momentum, so pi is equals to del L del qi dot. So pi is actually the function of qj dot and time t, and inverting to get qi dot, which is also the function of qj, pj and time t. Here qi dot is the generalized velocity. Now the variation of H dH is equals to dpi qi dot plus pi dqj dot minus del L del qi dqi plus del L del qi dot dqi dot plus del L del t into dt. So this is the variation of H, or we can write it in this way, that dH is equals to dpi qi dot minus del L del qi dqj minus del L del t into time into dt. So this is the variation of H dH. Now as we know that H can be written in this way, and from our previous calculation we know that the variation of H dH can be written in this way. We name it as equation 1. Now we can rewrite this equation 1 in this way, that dH is equals to del H by del Q dqi plus del H by del pi dpi plus del H by del t into dt. So here equating these two equations, we can see that this minus del L del qi is actually pi dot. This del L del qi is equals to pi dot from Lagrange equation. So pi dot is equals to minus del H by del qi, and from this term we can see that qi dot is equals to del H by del pi. So qi dot is equals to del H by del pi, and from these two terms, we equating these two terms, we can see that minus del L by del t is equals to del H by del t. So minus del L by del t is equals to del H by del t. So equating these two equations, we get these equations. So this set of equations are known as Hamilton's equations, and they are very helpful in calculations of mechanics. So this was our discussion on Hamiltonian and Hamilton's equations, and on our next class we are going to discuss about conservation laws in classical mechanics. Thank you everyone.